All right, guys. This stuff is tricksy. If you like to problem solve, if you like to solve riddles, if you like detective stuff, you might actually enjoy this a little bit because that's kind of what it's all about. If you like one way to solve something, if you like something black and white, very concrete, you may not enjoy this, but that's okay. Um, it you might, who knows? Anyway, we got to know these identities, and you've learned all this before. We'll deal with this in a second. But all this, cotangent is 1 over tangent. Cosecant, 1 over sine. Secant, 1 over cosine. We also know that tangent is sine over cosine, and cotangent is cosine over sine. You've learned all of that before from me, or at least you were taught it. Now let's talk about what I circled there. If I take tangent and I multiply it times 1 over tangent, what do you think is going to happen? You got tangent over 1, 1 over tangent, all that cancels out, and you get 1. It's the same thing for sine and cosecant, because secant or cosecant's 1 over sine. Same thing for cosecant and for cosine and secant, excuse me. So let's kind of use those properties there a little bit. So for A, we want to prove. That's all this is about, is just proving. It's not quite as intense as proofs are. We don't have to like give definitions and give reasons why something works and theorems and all that stuff. We just have some cold, hard facts, some concrete things that we have to prove and that we can use to prove. So tangent, we got some of the cosine and sine. Well, let's see if we can change secant. So secant is 1 over cosine. And secant is 1, or sorry, cosecant is 1 over sine, not secant. Good grief. Struggling today. Okay, I'm going to pen just a little thicker. Okay, good. So I got 1 over cosine x times sine x over 1. Reason why is because when we divide by a fraction, we flip the second one, right? So then I have tangent of x is equal to sine of x over cosine of x. Well, sine of x over cosine of x is tangent. So I have proved it. I am happy. I have done it. So the work, all this stuff, is actually the answer. This, what appears to be the answer, is really not much. You can write that down no matter what, and you're not going to get credit for it because the work is what we're looking for. Cotangent of x, cosecant, all that stuff, it kind of works the same way. I'm going to do it a different way just to show a little variety. Okay, and you could have done this one the same way too. Cosecant, yes, we know is 1 over sine of x. Secant's 1 over cosine of x. This time I'm going to multiply the top by cosine of x and the bottom by cosine of x. My program stopped working? It did. Hold on. All right, sorry about that. Yeah, I had a reboot, so my colors are different now. Sorry about that. Anyway, so we're multiplying everything by cosine of x. So down here, I get cosine of x over cosine of x. That just cancels out, so I got 1. And on top, so I got cotangent of x equals cosine of x over sine of x all over 1. Well, it doesn't matter. I don't really need the 1 there. And then cosine of x over sine of x is cotangent. Boom, got them. Now the next part. This is probably the most useful, most important. You don't have to know how we get these. I'll kind of explain it real quick. But all you got to really know are these 3 guys right there. Okay, and then any manipulation of these. So cosine theta plus sine of theta is the same thing as sine of x plus cosine of x. If you want to get one of these by himself, then move sine squared over. So then cosine squared x would be 1 minus sine squared x. Or if I wanted to get sine by itself, I move cosine over. So sine squared x is equal to 1 minus cosine squared x. And all that same stuff, like down here, if I want to get secant squared is all by itself, but I want to get tangent by itself, subtract 1. So tangent squared would equal secant squared minus 1, and yada yada. Same thing. Cotangent squared by itself. Cool. Now the reason why we get this Pythagorean theorem, cosine is adjacent over hypotenuse. So adjacent over hypotenuse, sine opposite over hypotenuse. So yeah, that's how we get that. Cosine theta, sine squared, blah, blah, blah. Flip it over to the back. You will need to memorize at least this one, sine squared theta plus cosine squared theta, for sure. You will probably end up memorizing it without knowing it. But yeah. So number one, we're going to change this to this. So sine x times cotangent of x is equal to cosine of x. So I can't really change sine, can't really change cosine at all, and I want to get it to cosine, so why would I mess with that? I'm going to change cotangent. So sine of x times, well, cotangent is cosine of x times sine of x. Those cancel out, so I get cosine of x is equal to cosine of x. Boom. I guess we're only going to box around it because our work is here, so I should have boxed around that. Okay, next one. We got sine of x, secant of x, cotangent of x to 1. Sounds like a hefty task. Can't change sine at all. Secant is 1 over cosine. Cosine. Cotangent is cosine x over sine x. Well, hold on. Let's see. Sine, sine. Cosine, cosine. Oh, what do you know? We got 1 equals 1. Makes us happy. All right, I got a few more here. 3 more maybe. Okay, what we're going to do here is we're going to look to see if I can change this guy to that. So I got cosine squared x minus sine squared x to 1 minus 2 sine squared x. All right, well, anytime we see, anytime you see a square, we should be always thinking cosine squared x plus sine squared x equals 1, okay? Now, if I want to maybe replace cosine, I want to get rid of this. I'm going to move sine squared over, and it's just kind of like substitution for when we did systems of equations. I'm going to replace cosine of x with what it equals. So if I move sine squared over, I get 1 minus sine squared x is equal to cosine x. So I can replace that. So I'm not going to write that. I'm going to write 1 minus sine squared x, still minus sine squared x. And we're trying to make it look like this. Well, just like when we have -1 minus 1, it doesn't equal 0, it equals -2. So same thing for this. If I have negative sine squared, it actually makes 1 minus 2 sine squared x. And what do you know? Once again, I'm happy because I got the answer. Number 4. This one's pretty easy, I think. Multiply this. Well, when you got x minus 2, x plus 2, it's a difference of perfect squares. You get x squared minus 4. Same idea. We're going to get 1 minus cosine squared of a is equal to sine squared of a. Well, anytime we got that whole squared business, we should be seeing that. Well, remember, if I go back a second, cosine squared is 1 minus sine squared x. So if I wanted to figure out so I got cosine squared of a plus sine squared of a is equal to 1. Well, if I subtract cosine squared a, that's what sine squared a is, right? So if I move this guy over here, that's what sine squared a is. So, yeah, pretty easy, I think. Done. Number 5 is a little tricky. Number 5 requires foiling or box method or any of that, and you really don't have to do any of that. You can do a couple of shortcuts. The first shortcut is just to square this. So cosine squared m. The next thing is you're going to multiply this times that and multiply by 2. So -2 cosine m secant m. And the last thing is to square this. So plus secant squared x. The reason why it's squared is because it's negative. Or sorry, the reason why it's plus is because it's negative. We want that to look like tangent squared x. No, I'm changing all my variables. I'm sorry. Still an m minus sine squared m. Okay. Alrighty. You should maybe see that cosine m secant m is just 1. Reason why is because cosine m and secant m cancel out. Because secant m is 1 over cosine, all that just goes away. So I'm left with plus secant squared m equals tangent squared m minus sine squared m. All right, next thing we should do is probably see if I can change any of this square business. So I can actually change both of those. We'll go at one at a time. Cosine squared m is 1 minus sine squared m. So then I got minus 2 plus secant squared m equals the same thing. You're probably getting tired of writing that. And then the last thing, secant squared m is the same thing as tangent squared m plus 1. Oh, we're there. Believe it or not, we are there. We have arrived. Check it out. 1 and 1 make 2. 2 minus 2 all goes away. So now I got negative sine m squared plus tangent squared m. So that's like saying tangent squared m minus sine squared m. And what do you know? We got there. You made it. Congrats. Give yourself a high five. Okay, last one. Number 6. Converting it to that. Anytime we got fractions, so 1/2 and 1/3, we got to find a common denominator. That would be 6 and 6, and then you do the whole 3 and then 2 thing, all that stuff, right? So same idea. So we got secant x. My common denominator is going to be both of these. So sine x, cosine x. Now this one needed a cosine x, so I'm going to multiply that one times cosine of x. Minus, once again, I got sine x, cosine x. This one needed a x, so I'm going to add another, needed a sine, so this one's going to have another sine. And that equals cotangent of x. Well, next thing, secant x, cosine x. Secant's 1 over cosine. Cosine's cosine. They cancel out, and I'm left with 1. So I got 1 minus, that's sine squared x, over sine x, cosine x, equals cotangent of x. Well, 1 minus sine squared, I got that squared again, so I got to use that Pythagorean identity there. So that's going to be cosine squared. So I got cosine squared x over sine x cosine. You can't even see that. Cosine squared x over sine x cosine x equals cotangent x. We're almost there. Stay with me. Cosine squared over cosine, that's just going to make that go away. Give me 1 cosine x on top. Cosine of x over sine of x is cotangent x. We made it. We are there. Cotangent of x equals cotangent of x. We are donezo. Good job. See you tomorrow.